Okay, we're in section 31 of the homework. And again, we're going to work through the homework. Again, I can't say this enough times to you. It's really you need to work through the homework. It's not me working through the homework. What I do is I provide questions for you. I provide pictures for you. I provide work as well. All right. Now, when I'm at the whiteboard, I'm just simply talking through my work. And for some students, that's helpful. For other students, it's pointless. All right. You need to decide what's working for you. But the bottom line is you need to learn the material as is being presented to you. All right. So I'm going to switch to the whiteboard as we always do. And I'll work through the problems. And just give me a moment to do that. And certainly as I'm reading through these questions over here, my encouragement to you is to read and pay attention to what you're reading. It isn't just reading and saying, I got the words down, but it says they gave me a picture over here. I see the picture, the abscissas in minutes, and the ordinate is in miles per hour. And it says over a 3-minute interval. All right, so I clearly see that. And what do they give me? Velocity, and they give me minutes. I see that. All right, so what do they say? Determine the distance traveled. Well, I got to remind myself that distance is equal to rate times time. All right, so I see these little pictures they give me, and I'm going to start to shade it in for you. And someone says, why do you shade it in? You don't have to, but I like to shade in these regions over here. So I'm going to shade this region over here. And then I'll shade this region over here. And I'll do one at a time for you. And what's this represent? Area under that curve. And the curve is, it's in pieces. And then this guy over here, I'll put the next one down. And you might say you're delaying the inevitable. I got to put work down, right? This is not work, by the way. It's just me understanding the problem. And let's talk about it. And let's talk about the area of the first region, which is, this is the first region here. And he's going, the rate at which he's going in this first region is going to be what? Well, he's going, the rate's 10 miles per hour. Times the time, well, that's just for a half of a minute, right? So 1/2 of a minute. I got troubles, and the troubles are there's an incompatibility of time unit. So I'm going to say distance is 10 miles per 60 minutes times 1/2 of a minute. And I'm going to do the arithmetic for you. This will be the first one. This is this guy right over here. I'm just doing this. Again, if this takes your time, that's fine. If it's quick for you, that's fine too. So it's going to be what? It's going to be 1/6, 1/12. Minutes cancel off, and I get a mile. All right. Now, let me do the next guy. Well, this is the first guy. Let's do the next guy. And what's the rate there? It looks like 25 miles per hour. That's 25 miles per hour. And there's 60 minutes in an hour. And how much time is given to me there? Well, it looks like it's going from 0.5 to 1.5. So 1 minute. Well, minutes cancel off. That's good news. And I get 25 over 60. And this is going to be in miles. I'll do the arithmetic later. Let's see, 25, 5 goes into 25 5 times, right? And 5 goes into 60 12 times. That's pretty simple. Let's go to D3. I'm getting a little better at this. And what's D3? It's this guy over here. And what's the speed? 15 miles per hour. And that's 60 minutes. I'm getting better at this. And he looks like he's going for a half of a minute. Oh boy, things I guess cancel off. Minutes cancel off. And that would be 1/8 of a mile. Let me check, make sure I did my arithmetic right. 15 goes into 64 times, and 2 times 4 is 8. Looks pretty good. Let's go the last guy over here. And I realize if you're slow at arithmetic, this is really difficult. You got to get good at arithmetic. This is 20 miles. And by the way, I'm not saying I don't make mistakes per hour. That's hour, sorry. Per minute, I'm sorry. I made a mistake over here. Let me get my eraser out. And how many minutes is that? 1 minute. I'm doing this last guy here. So what do you get over there? 1/3 of a mile. And what's the question is distance? I got to add all those distances together. Let me do that. And I'm adding this distance to this distance. There's going to be 4 regions, right? This distance, that distance. And 1/12 plus 5/12 is 6/12, which is a half. That's these two here. And then 1/8 plus 1/3, that's going to be something to do with 24th, right? So 3 plus 4. Right, did I do that? 3 plus 4, yeah, 7. Boy, I got to do arithmetic now, 24. And I'll put the unit down later. Let's see, that would be 12 plus, I did a mistake somewhere. Let me take a look. 1/12 and 5/12, 6/12, which is a half, 1/8 and a third, 24th. And you're going to get 3 plus 8, 11. I see it now. My eraser out. Let me check that again. That's 8 plus 3, 11, yeah. So 12 plus 11, 12 plus 11, 23, right? And what's this going to be? Miles. Okay. Let's go to the next one. Determine the distance traveled over the interval between 1 and 2.5. Well, I'll do that one. I'll do it in different color. So 1 to 2.5. So let me point out what they mean by that. And I'm getting better at this. 1 to 2.5, right? So they're talking about this area now. All right, I think I can write that down. And what's that going to be? Well, that first column, I'm looking at this one over here. That's going to be 1/2 times, what's the height of that? 25 over 60. I'm aware of writing that in terms of 60, not in terms of per hour. What's next guy going to be? I'm doing the next block, this guy over here. That's still going to be a half. And that speed is going to be 15 over 60. And then the last guy, again, the interval length's 1/2. And what's the speed of that guy going to be? It looks like 20 over 60. I got to do the arithmetic now. Kind of aggravating. So I can put 120 down. That's going to be 25 plus 15 plus 20. And that's 25, 30, 40, 50, 60. It's a half. So what's this half mile? That's what they said. All right, let's keep going. And not so bad. This one, a little tables. Table a little different. I got to read it to you, but I'm not going to draw a picture of this. I guess I could draw a picture. But it says, rainstorm hits a city resulting in record rainfall. It says the rainfall rate, which is RT, is recorded in centimeters per hour. So let me write this down next to this. This rate over here is in centimeters per hour. All right. And they go on to say, the following table, T is, number of hours since midnight. So this is in hours. So 0 to 2 means, midnight to 2 a.m. And then the next thing is the interval between 2 a.m. and 4 a.m., 4 and 9 a.m. You get the idea, right? These are in hours, right? So it says, where T is, the number of hours since midnight. Keep reading it over and over again. Compute the total rainfall in the 24-hour period. Well, that looks pretty easy to do. I mean, it's going to be, let me write this down for you. So in the first, it's going to be, this accumulation is going to be rate times time. And I think I can write that down. So the rate in the first 2 hours is 0.2. And there's 2 hours there. Plus, what's the next one going to be? Well, the rate is 0.1. And how many hours are there between 2 and 4? It's doing that for 2 hours. Let's do the next one. And again, I'm just clipping these off one at a time. Its rate is 0.4. How many hours are there? Well, it looks like 5 hours. All right. Plus, I just did this one over here. 9 to 12, its rate is 1. And 9 to 12 is 3 hours, right? Plus, this is an 8-hour period now. 12 to 20 is 8 hours, right? Its rate is 0.6. And what's over here? That's 4 hours, and its rate is 0.25. All right, I'm not going to bore you with the arithmetic. I just want to make sure you understand you should do the arithmetic. Let me just check to see if I put these down right. I got this one. I got this one. I got this one. I got this one. I've got this one. And I've got this one. Make sure you can do the arithmetic though. So you should check this. So I'm going to say I need a calculator to do that. If you do, you do, but I hope you don't. All right. Let's do number table 3 now. And you'd have to know R6, L6, M3. Again, I'm not trying to make fun of people, but what happens a lot of times people in exam, they show up and they say, what's R6? What's L6? What's M3? The only thing that person's communicating to me is that they've done little work. They've done little work. You often hear these questions on exam is, what does this mean? What does that mean? What does it again say to me? It says, I've not done work. It's like almost showing out at a job and you're at your first meeting. And at the first meeting, they said that, you were supposed to do something and it was a job that you had to do. And you get there in the meeting and they say, how'd the job go? And you look at them and say, what job are you talking about? I was just here for the paycheck. That doesn't go over well. All right. Doesn't go over well. They'll probably give you a paycheck, but they'll ask you not to come back. All right. So here's the deal. I'm going to read it to you. And as I'm reading this thing over here, I'm going to read it. So they want R6. What does R6 stand for? Right endpoint. And I'm going to put the intervals down here now for you. So I know it's endpoint. So I'm going to put down, looks like it goes from 0. And then they got, let's see, 0.5. And then it goes to 1. And then it goes to 1.5. I think you get the idea what I'm doing over here, right? I'm putting this thing over here. And then 2. They're equal partitions, by the way. It makes it nice and easy for me. 2.5 and then 3. All right. So what does R6 mean? It means right endpoint 6 intervals. So it's going to be this. That's right endpoint, right? Whatever that is, this right endpoint over here, this is right endpoint. Let's see if we can get 6 of them, all right? So it's going to be 1, 2, 3, 4, 5, 6. Let's write R6 down. Well, what do I know about each partition? It has a base length. Every single one is equal partition. The base is the same every single time. And what's going to be 1/2. Now, what do I have to do? I have to put the values down of the right endpoint. So I need to know what this value evaluates to up here. And what's that going to be? 12. What's next one going to be? I'm reading this from my table, by the way. I'm doing the right endpoints. 12, 18, 25, 20, 14, and 20, right? So I'm going to look at, I get 6 of them. 1, 2, 3, 4, 5, 6. What do you expect to do? Add it together and get the number. Now, I'm not going to do that for you. I'm going to ask you to do that. I want to make sure that this is right. I'm looking at 1/2, 12, 18, 25, 20, 14, and 20. I got that. Now they want me to do L6. What's L6? It's the left endpoint now, the left side of the interval. So what do I get? Still 1/2. I'm going to do the lefts. So this is the first left over there. What does it evaluate to? 0. And then I'm going to go 12, 18, 25, 20, and 14. Again, I don't want to do the computation. I'm going to say you can do the computation. But let's see if we got 6. 1, 2, 3, 4, 5, 6. Did I get the same thing I got over here? I don't know. Let's take a look at it. 0, 12, 18, 25, 20, and 14. Looking good. Now, what's M3? You did ask for M3, right? M3 are midpoints. So I need 3 partitions. Right? This is one partition, this is another one, and this is another one. So let's write this down. What's the base length of those partitions? 1 unit. What's the midpoint? Well, the midpoint's going to be here, and then here, and then here. So what's, the value at 0.5, it's 12. What's the one at 1.5 is 25. And what's the other one at 2.5 would be 14. Let's see if we got that right. Base length is 1, 12, 25, and 14. Good. And again, we would expect you to do the arithmetic in that one as well. Let me repeat this. If you have trouble with arithmetic, come by, and certainly we can give you advice, certainly, practice to arithmetic, but you got to get arithmetic down. You have to get simple arithmetic. I'm not saying difficult, but it's simple stuff. All right. And let's keep going. All right, let's go to number 4. All right, number 4 says consider f of x on the interval 3x plus 4. I'm going to draw my lousy little picture, by the way. And I'm going to go between 0 and 4. So at 0, it's going to be 4. And at 3, it's going to be 9, 13. I'm not going to say I'm doing the best picture here, but I'll put something over here. I'll write the point down for you. And the point's going to be over here would be 3, 13. And this is the region they're talking about. I'm going to shade it in for you. Okay, this is the second time we're seeing this L6. Oh, I made a mistake. L6. So I need to take this partition here and divide it into 6 equal pieces. Well, if the length is 3 and I'm running into 6 equal pieces, its length would be 1/2 each base. The left endpoint is going to be what? Well, I'm going to write this down in notation where f is a function of x. And what's that function? 3x plus 4. So what do you get over here? F of, what's the first left endpoint? 0. Then what do? I have to move over 1/2. That's going to be f of 1/2. And there's going to be 6 of these. I'm going to move over another 1/2. That's f of 1. I'm going to move over another 1/2. That's going to be 3/2. And I keep moving. So when do you stop moving? Until I get to that last left endpoint. So f of, let's see, 1, 2, 3, 4. I'm in the 5th one. 1/2 over would be 4/2. And then f of 5/2. All right. So I'm going to claim I'm done with that. I'm not going to do the computation. I'll let you do that. But again, if you want to come by during office hours, and I'll do the computation for you to show you that it can be done. I'm just checking to see if I got this thing over here. And I see f of 0, f of 1/2. They put decimals down, f of 1, f of 3/2. That's 1.5. 4/2 is 2. Yeah, I see it. I see that. Make sure you can do the computation now if you can't come by during office hours. They also want me to do R6. That's right endpoint. That's 1/2. And what do you get over there? Well, now I'm at 0, but I move over 1/2. So I'm at f of 1/2. I move over 1/2. That's f of 2/2, which is 1. I move over 1/2. That's going to be 3/2. I move over 1/2. That's going to be 4/2, which is f of 2. I move over 1/2, which is going to be f of 5/2. And I move over 1/2, it's going to be f of 3. Let's count them up. 1, 2, 3, 4, 5, 6. Let's look at our key, see if we got it. I'm looking at it. I'm seeing this over here. Good. I didn't do the computation though. We're expecting that you can do this computation. We're expecting it. Again, I repeat this. I know it sounds like a broken record to you. If you have trouble with arithmetic, you want to see me do the arithmetic, I don't mind doing the arithmetic. All right. Let me just see if I've got, I noticed there's an artifact that we're going to get rid of. That's what f of x is. Now where they say find area, use geometry to find area. So I'm going to do that, see if I can do it. And some people make a mistake with this. And at one point, I'm going to try to do that by using geometry. So I'm going to do this area first because it's a rectangle. I know to do that, right? What's its area? Well, it's a rectangle, so its base is going to be 3, and its height is 4. I want to do this guy's area now. That's a triangle. 1/2 times the base. What's the base there? It's still 3. What's the height of that? Well, it goes up to 13 and it bottoms out at 4, so it's 9. All right, this is 12, or 24/2. And this over here is going to be 27/2. I have to add those two numbers together, and that's going to give you 51/2. Check the key, see how we did. I got the 51/2. You should notice that 51/2 is actually average of these two numbers over here. Let me show you that. I'm going to show you the average, same number. And this can be 2. And 93 plus 111 is a quarter, right? That's going to be, let's see, 94, 204 now. And that's going to be what? That's going to be 102 halves, 102 halves over 2, which is 51 halves. Yeah, 51 halves, same number. Okay, that's good news. All right, let's look at this one on number 5. And again, they tell me what the function is, and they give me a picture. Now, my question is, what do they want me to do with the picture? They want me to calculate the area of the shaded rectangles. And I got to be honest with you, to do that, what do I know about every single rectangle? Its base every single time for those rectangles is 1. So I know the bases are 1. So all I got to do is get the heights. So I got to get the height. I got to get the height. I got troubles though. I'm not seeing any numbers on the y-axis. I'm not seeing any numbers at all. So what I'm going to do over here is I'm going to call this the function, which is y is a function of x. So what's the first thing? It looks like a midpoint, right? So it's going to be y evaluated at minus 2.5. Yeah, it's kind of nasty, right? What's the next one going to be? Plus y evaluated at minus 1.5. That's the second point. Plus y evaluated at minus 0.5. Plus y evaluated at 0.5. Plus y, they're all midpoints, by the way, 1.5. And plus 2.5, y of 2.5. All right. Again, I realize that somebody will say, I can't do that arithmetic. Don't ask me to do that. I think you can. All right. How do you do that? Plug it in over here. I'm not going to do that in front of you. However, I'm not opposed to doing it for you. Right. If you want to come by during office hours and see me do that arithmetic, I'll be more than happy to do it for you. And it might be painful. The only difference in my answer key over here, I want to point out the answer keys over here, is I didn't call it y of x in the answer key. I called it f of x. So that's the only difference. This is also f of x. And let's see if I got that right. Minus 2.5, minus 1.5, minus 0.5, 0.5, 1.5, and 2.5. Again, I would recommend you try to do that on a calculator, see if you can get it. All right. So let's take a look at the next one. And over here, they say, which approximation do these rectangles represent? It's going to be, let's go back and look at the picture. I'm definitely doing midpoints. And how many are there? 1, 2, 3, 6 of them. So it's M6. Right over here. M6 should be circled. We did it. We got it. Success. All right, let's do this one over here. And this says R5. All right. Again, I repeat this. People come up on exams and say, what does that mean? And even if I told them what it meant, which I don't normally do, it still wouldn't help them. They haven't practiced. They've done no homework. All right, let's talk about R5 now. Well, let's look at our partition, first of all. It's between -1 and 1. And what's the length of that is 2. That's the length of that interval. We're going to divide that by 5 equal parts. All right, so R5, every single base is going to be 5 over 2. Then what do I do? Well, I got to start somewhere. So where am I starting? -1, but I have to move over, right? I'm sorry, I made a mistake in copying. I said something and I wrote something down different. Sorry about that. The length is 2 and I'm dividing by 5. All right. So I want to point out what we're doing. We're at -1, but we need to move over 2/5. Now, when I'm doing this, I like to count in the same unit. So I'm going to say -1 is -5 over 5. I'm sorry. Again, I must be daydreaming or something. Let me get my eraser out. That's -1. Now, if you move over 2/5, where would you be? -3/5. If you move over 2/5, you'd be at -1/5. If you move over 2/5, you'd be at 1/5. Then you'd be at 3/5. Then you'd be at 5/5. I want to point out the right endpoints. These are the right endpoints. How many are there? 5. Let's write this down. So it's going to be f of -3/5 plus f of -1/5. We'll look at the key later. Plus f of 1/5 plus f of 3/5 plus f of 5/5. Let's count them up. 1, 2, 3, 4, 5. Let's see if we got the right answer. What I mean by that, I'm not doing a computation for you. I'm going to say that you can do the computation. Let me just pull this over and you know, I can get my, maybe not. Let me just do this over here. Sorry about that. I'm a little confused here. Let's get my red pen out. 2/5. I got that right. F of minus 3/5. F of minus 1/5. 1/5. 3/5. Wow, we got it. Again, I realize for some students, arithmetic's really kind of annoying to them. You know what? Practice. It really can't hurt to practice that. You should be able to get that number. I want to repeat this. If you're not getting the same numbers I'm getting, maybe there's something wrong. All right. Bring it to my attention. And I don't mind going through it again with you. I make mistakes too. All right. Let's look at the next one, number 7. And number 7 says write the sum. Oh, geez, I have to write a sum down now. So what I'm going to say is that they kind of give it to me. And what I mean by that, they're kind of giving it to me. Right. So I'm going to write this down. They're kind of giving it to me. I'll put this over here. They're kind of saying it's a sum where the terms are of this form over here. I'm not going to use n. I'm going to stop at n though. I'm going to use the letter k. And it's going to be k plus 4, k plus 5. All right, so I know we're ending there, but then I say, where are we starting? So I have to look back at the original and I'm seeing it. And it says it should start where this is 6. So what would make this 6 a 2? I'm going to write that down for you now. By the way, I'm going to check this now. So if I put a 2 here, what would you get? You would get 2. This would be 6. That would be 7. I'm seeing that there. 2 goes to 3. What do you get next? That would be 3. This would be 7. That would be 8. I'm seeing that. Now, if you stop at n, do you get what you expect? N plus 4, n plus 5. So this is my answer. Again, what do I check? I check it with this thing over here and make sure it's the same answer. And I'm seeing it. K equals 2 to n, k over k plus 4 times k plus 5. Looks pretty good. All right, this one says calculate. Oh boy, this is tough. All right, kind of reminds me the question you were given in Math 120 when you were introduced to summation problems. And there's many ways to do this. I'm not saying there's only one way, but you could write this down as, let me see, 101. And by the way, I have seen students do this on exam, by the way. 102. Whoa, I made a mistake already. Plus 103. And I kid you not, I've seen students write this on exams. At least they know what a sum means, by the way. 104. Then they keep going. And I'm saying they keep going until they hit 300. And then they try to add all those terms together. I'm saying that's just plain madness as far as I'm concerned. But you could do it. You get the right answer. I'm not going to deny it. It's thuggish. People see you do that, say, why are you doing that? Right? So I have to write down what I know. And what I do know is I know the sum of the integers, and I'll write this down, I equals 1 to n of the integers I is equal to n plus 1 over 2. I do know that much, right? How do I know that? Well, you were given that in Math 120. You proved it by using PMI. And then if you're in my class, you'd also derive it using polynomial expansions. And that's done in my Math 120 class. I'm not saying that every teacher does it. A lot of teachers don't do it because they think it's too tough for the students. I just don't think it is. I think it's something that's easy to do, but it's something that you should know at this point. So what I'm going to do is I'm going to say the sum of J equals 101 to 300 of J is equal to the sum J equals 1 to 300 J, but I got to remove something. And what am I going to remove from it? I have to remove the first 100 terms. So I'm removing J equals 1 to 100, and that's going to be J. Do I know what that is? Let me see if I did that right. So if I have 1 to 300, and then I subtract away 1 from 100, I'd have 101 to 300, which is what I wanted. So let's write this down. So what's going to be, I'm using this formula. It's going to be 300 times 301 over 2 minus 100 times 101 over 2. All right, that's not so bad, right? Now, by the way, I'm going to say you should do the arithmetic, but I realize for some students, they say, I can't do that. I think you can. My common denominator, I'm going to factor out 100. This is me, by the way. I'm not saying that's what you would have done. And that would be 3 times 301, which is 903, minus 101. I factor out 100, right? Boy, I got some work to do, don't I? 100. What's 903 divided by, I'm sorry, 903 minus 101? It's going to be 802. By the way, I'm not beyond making error. And I really want to emphasize, I make error all the time. This is going to be 100, and this would be 401. So I think I can write this down now, 40100. Look at my K, see how we did. Wow, got it right, miracle. All right, I mean, I am pretty bad at arithmetic. So let's go to number 9. Oh, number 9 looks tough. Oh boy, I got to do some work here, don't I? And let's take a look at that. And I got to do it. I got to write it down. I'm going to expand it. And that's going to be sum. And let's see, that would be 64 j squared plus 16j plus 1. Well, I'm going to expand that guy, and I'm starting to see things here. 64 times the sum j equals 1 to 30, all right, of j squared, plus, let's see, 16 times the sum j equals 1 to 30 of j, plus the sum j equals 1 to 30 of 1. Well, I'm going to do the easiest ones first. That's on the end. This is going to be 30 times 1. This one's pretty easy to do too. It's a sum of the integers. It's going to be 16. The formula is n plus 1. So that's going to be 30 times 31 over 2. The sum of the squares is a little more difficult. I realize that. And some students, they just can't remember it. But I know I divide by 6. It's going to be n, which is 30. N plus 1, which is 31. And then it's going to be 2n plus 1, which is going to be 61. All right, now I realize for a lot of students, it's overwhelming. It really is. It's tough to do. It's not that bad, but you know, I could go through the arithmetic with you. And let me go through some of the arithmetic, not all of it. And the last term is 30, right? And you know, I'm going to say 2 goes into 30 15 times. So you get 16 times 15 times 31. Let me see if I can do this. 6 goes into 35 times. And what do you get? 64 times 5 times 31 times 61. Now, granted, I realize someone said, do I need to do that arithmetic? I would like you to try and see if you match this number over here. All right. All right, let's do this one over here. It's problematic, and I know it's problematic. And so what I have to do is I have to rewrite it for you. So I'm going to rewrite it as it's really, write this down, limit. Yeah, that's important. N goes to infinity. I'm going to rewrite the sum now. It's going to be 1 over n cubed times the sum of 3s squared minus 5s minus 5, where s starts at 1 and it goes to n. Boy, that's going to be some work. Let's put this down. So what do you get? Limit n goes to infinity, 1 over n cubed times, whoa, this can get tough. Let me get an eraser out there. I don't want to put the parentheses there. Let's see. It's going to be 3. I need to remember the sum of the squares, right? So it's going to be n plus 1, 2n plus 1. And they're the formulas that were proved in Math 120, and they were derived if you were in my section of Math 120. Most teachers don't derive it, though. Minus 5 n plus 1 over 2 minus 5n. All right. I got work on my hand, by the way. So what's the work? I got to do the limit. So I got to do this. It's going to be tough. So limit as n goes to infinity. I got to multiply this out now. I'm going to do it in 3 terms. All right. So what do I see first? I would see 2n squared. Let me see if I did that right. 3 goes to 6 twice. One of the n's canceled off. What do you get over here? Well, you get 2n squared plus 3n plus 1. I think I did okay there. Oh, I got to keep going. All right, let me take a look at this. Minus, I'm doing this whole thing over here. This should be 5n plus 1. And then I'd get what? I get 2n squared, right? Minus 5 over n squared. All right, let's take a look what they want me to do. They want me to do the limit, right? Find a, yeah, evaluate that limit. I think I'm ready. I want to point out why I'm ready. This goes to 0, and this goes to 0. And where does this one go towards? Well, looking at it, divided by the highest degree variable would be n squared. It looks like it's going to 2. So what's the limit over here? I'm sorry, I said 2. It's not 2, because 2 divided by 2 is 1. I have to move my eraser around. What's the limit going towards? 1. Whoops, I did it again. Okay, let me just go through that because I misspoke for a second there. And what I said to do was, I'll write this down. Looking at this limit over here, what you do is divide by the highest degree variable, which is n squared. This would become 2, that would become 2. These go to 0 because we 3 over n, that's 1 over n squared. So it'd be 2 over 2, which is 1. So I'm going to claim again it's 1. All right, let's look at what they got, and they got the 1. All right, let's go to the next page. I think I go to the next page, yeah. And let's see if we can do this one over here. And this one, I got to evaluate the limit as n goes to infinity. And, my understanding over here is that for some students, they're able to memorize how to do these things. And that there's nothing wrong with that. But I want to write down, just Rn for the first part. I want to see if I can write that down. And what am I doing? I'm taking the length of the interval, which is 3, and I'm dividing by n equal parts. And I'm going to do right endpoint. And I got to write this down for you. If it's right endpoints, what's it going to be? It's going to be f of, well, let's see. I'm starting at 1, and I'm moving over 3 over n. And then you'd keep marching along. I'll put this over here for you. The next one's going to be f of 1 plus, well, I move over 2 times, right? Times 2. And I keep doing this until I get to the end, which is going to be f of 1 plus 3 over n times n, which would be 4, by the way, which is exactly where they're stopping. So I'm going to write this as a little differently. I'm going to write Rn down as a sum problem, and then I'll figure it out. It's going to be 3 over n times the sum I equals 1 to big N f of 1 plus 3 over n I. Now I got that covered. All right, I'm still writing that as Rn down. This is really tough for a lot of students. And this is 3 over n sum I equals 1 to n. What's f? 71n. I hate that number. I got to write it down. Man, it's terrible. So it's going to be 71 times 1 plus 3 over n I plus 142. I got to do this whole thing here. It's a nightmare. I know that. Because I can't do that. Why do you ask me to do that? It can't be a nightmare. It's got to be easy. So I'm going to kind of like, maybe simplify things a little bit. Rn, 3 over n. We have a key 2 to look at. The sum I equals 1 to n. I'm going to simplify the sum n and see what I get. I get 71 plus 142. I'll write this on the side. That's 3. 7 4 is 11, 213. Okay. And then what do you get? You get 71 times 3. That's 210, 213. Is that right? 210. Yeah, 213. I'm going to check it again. 71 plus 142. Yeah, 113. 213, I mean. Yeah, I think I'm doing okay. Rn, 3 over n times 213 times n. I'm moving the sum symbol now. Plus 213n. And the sum of the integer from 1 to n is going to be n plus 1 over 2. Wow, that was easy. That's an n. Let's write this down. Rn, 3 over n, 213n. I'm just simplifying, by the way. We'll get to it later. And what do you get over there? 213 n plus 1 over 2. All right, let's keep going. Rn equals 3 times 213, which is 639. The ends cancel. Plus, boy, what do you get over there? Let's see, 639 over 2, n plus 1 over n. All right, let's go back over here and let's see what we got over here. Let's see if we got what they said they got. Yeah, we got what they got. What am I going to do now? Limit as n goes to infinity. Limit as n goes to infinity of Rn. And I know it's work, by the way. I'm not saying it's not work. And I think I can do that limit. And what do you get over there? 639. Again, this is Rn over here. And what do I guess I would get plus 639 over 2 times this guy's limit, which would be, divided by the discrete variable would be 1. So what do I get over there? I got to do the arithmetic, and I hate to do it to you. So it's going to be 3 times 639. I got to do the arithmetic. 1800, 90, 27, 7, 9, 10, 11, 9, 19, 17. Hope I didn't make a mistake. No, I got to look at it, don't I? Yeah, 1917 over 2. I was looking at the wrong answer, by the way. All right. Someone says, I can't do these because they're too difficult. You got to try. I mean, if you give it up at this level of the game, it's going to be really tough for you. But this one, again, the numbers are killing me. They really are. This is 0 to 2, Riemann sum again. And I'll write it down. It's, I'll write Rn down first. What's the length of the interval? Well, it's 0 to 2. That's easy. Its length is 2, and I'm dividing by n, so 2 over n. I'm doing right endpoints, so what I'm doing f, and what I'm doing is I'm moving over 2 over n from the beginning part, which is 0, so it's going to be 2 over n. And the next one's going to be f of 2 over n. I move over twice, and I keep doing this until I get to the end, which can be f 2 over n times n, which would be 2. Let's write this down as a sum. Rn 2 over n times a sum I equals 1 to n f of 2 over n times I. I got the sum written down. Now I got to get the what f does to it. And it's always nasty. I know that. And it's going to be sum I equals 1 to n. And what do I do with it? Well, it's going to be 48 times the argument squared, which would be 4i squared over n squared. Hope I didn't go too fast with that. So 48, and then that argument squared, which would be 4i squared over n squared, plus 64 times the argument, which is 2i over n. I got some work to do, don't I? So Rn, 2 over n, sum I equals 1 to n, 48 times 4. Let's see. I don't want to make any too many mistakes. 4 times 4. Let's see. 4 times 48, 160. And then 32, 192. I squared over n squared. Okay, plus 128 I over n. Well, I got to keep going, don't I? Let's keep going. Rn, 2 over n. We got a key to look at later. Don't worry about that. So it's going to be 192 over n squared. The sum of the integers squared is going to be n plus 1 to n plus 1 over 6. Well, that looks tough, doesn't it? Plus, what's going to go on? 128 over n. The sum of the integers is going to be n plus 1 over 2. I got to simplify now. That's the problem. All right, it really is. So Rn, and I got to do this in pieces, okay? I'm a little slow at it too. So let's see. Let me do this first term. I'm going to divide by 2. This would become 3. Let's see, that would be 96, right? Yeah, 96. So 96 thirds. And then I get an n squared. Oh no, I get n. That's even nicer. Let's get rid of that. And then what do I get on top? I get n squared. I'm sorry, n plus 1, 2n plus 1. Let's do the next guy. That's going to be 64 n plus 1 over n. All right, I got to keep going. It's tough. It's not getting easier, is it? And you're going to get, I got to multiply this out now, right? So let's say 2 times 96. That's going to be 180, 192 thirds. And then you're going to get n squared on the bottom, 2n squared plus 3n plus 1. Let's see what we get over here. 1 let's see what we get over there. 128 n plus 1 over n. All right, let's take a look. And I want to see if we can do the limit now. The limit as n goes to infinity of Rn. can do it. 192 over 3. And this guy's limit here is 2. And this guy's limit here is going to be, what's it going to give you? Oh, I'm sorry, it's n squared. Let me see if I did that right. N times n is n squared. Yeah, this could be 0. So what do you get over here? I got to do it. 200. Let's see, 200. Whoops. 180 and 4, 8, 384. I think I made a mistake somewhere. Let's see. Someone says, how do I make a mistake? I'm looking at this answer and I don't have that answer. So let's take a look at it and see what went wrong and where it went wrong. All right. I got to look at my work because my work's a little bit different than the work that's over there, though. And where did I go wrong? 128. Boy, this could be exhausting. It's almost the last page. Let me see what the last problem is. Oh, no, that's not the last problem. Let's see where I went wrong. I'm looking step by step. I want to get to this stage over here, see if I got that right. So that's going to be I squared. I got that. Let's look at the next one. I think I might have done something wrong with the next one. I think there might be something wrong with this over here. Let me just take a look at that. 64x. And I'm trying to find the error. Oh, I think I found it, but I have to carefully look at it. I'm looking carefully. I hope you're looking carefully too, by the way. 64. It's always tough to see the error. I know sometimes I would do the problem over again, but I don't want to do that. 64. $128i. Oh yeah, I see it. I see it now. And they point out what I'm seeing over here. These cancel off now. I didn't see that before. And then when I do that, I do get this. I don't know why I said n squared over here. Let me just cross out. I got to start to erase things now because I know there's an error and I want to get rid of the things that are below the error. Right? I want to get things below that error now. I want to get rid of this nonsense over here. And I know that's tough. Someone says, do I need to do that? Yeah, you need to get the right answers. So let me just push this up now. Get my eraser out again. Get rid of this business over here. And this n disappears here. Yep, that was what I'm saying. I just found it. What do you get over there? Yeah. Let's multiply this out now. At least I think I found my error. What do you get over there? Let's see, 180, 192 thirds. And this would be n squared here. 2n squared plus 3n plus 1. And this would give you 128 n plus 1 over n. And I could take the limit now. And I'm just hoping I'm not making another error. It's going to be 192 thirds times 2. We did that limit before, by the way. And this guy's limit is going to be 128. All right, that's done. And let's see what we get. And I'm making common denominator 3. 3 times 192. I'll write this down. That's 300. 270. And 6. And then I'm going to add 128 to it. 3 times 128. What's 3 times 128? Let's see, 360 and 24 and 384. That's a problem, right? 8 and 7, 15. 6, 7, 8, 9, 50. No, I still think I'm making an error somewhere. Where is that error coming from? Got to erase this business over here. This happens too. I'll tell you, it happens, in these type of problems. If I were an exam now, I would walk away at this point. I wouldn't waste my time with this. I'd say I did most of my good work above it. All right, let me erase this over here. And I got to look at it again. And where's it going wrong? 2n squared. Let's take a look at that. 96. Oh, 3 goes into 96. I'm going to go erase again. I've seen another error. Three goes into 96 32 times. Boy, it's good to look backwards. 3 and 96, 32. 32 times 2 is 64. And then you get n plus 1, 2n plus 1. And then what do you get over there? I did the 3 to 96, which was 32. 32 times 2 is 64. And plus 1. I get n squared. And then I get 64. And plus 1. I'm sorry, 128. Sorry about that. Errors all over the place today. And I can do the limit now. N goes to infinity of Rn. What do you get over there? You would get, just doing the limit, I could do a limit quicker now. It's going to be 128 plus 128, which is 256, which is what we got over there. Sorry about that. Again, mistakes happen. I guess part of the reason mistakes happen is, if you work too hard, too long, you make mistakes. All right. Let's go to the next question. Next question, I want to be honest with you, for a lot of students, these are difficult, but looking at it, making a stab at it might be helpful. Not making a stab at it might be very, very difficult. But I'm looking at it and it looks like f of x might be x to the 9th power, looking at that summation. I'm not sure though. And looking at the interval, I'm going to say the interval has length 1, and it looks like we sure are starting at 0. So I'm going to say 0 to 1 is the interval on which it occurs. Now let's see if that's true. If I were doing that and I were writing down a Riemann sum for that, the length of the interval is 1. I'm dividing by n. And what am I doing? I'm doing a sum of f evaluated at the first right endpoint, which would be 1 over n. And then I go to the next one, which is f of 1 over n times 2. And I go all the way to the n, which would be plus f of 1 over n times n. And that looks like the sum they have written down there. Looks pretty good. So I'm going to claim the f of x looks like f of x equals x to the 9. I'm going to say that. And the interval looks like it's between 0 and 1. And I'm seeing that right over here in the answer key. All right. So I realize that this is, maybe a longer exercise. I did get stuck, so it made it longer for me. But you can get stuck too. And that's important. You get stuck, you try to get unstuck. All right. Thank you for paying attention though.